So we have Cloudshell, and we got disconnected with the AKS browse from the Kubernetes dashboard. So you can see the 8001 is not open, it would say, because it disconnected the previous session, but we couldn't, because the Azure shells, Cloud Shell would disconnect after every 20 minutes. So it was idle for 20 minutes and it disconnected. So let's see whether if we can connect with the admin credentials. It actually do not make much sense, but let's give us okay. 1001 is not open. Okay, so we can give some time to. We can't. Yes, one thing we can disconnect by triggering the pods. So let's go run our pods. Let's restart our pods. kubectl get pods. So kubectl get pods. So let's make it clear. kubectl get pods would give me the pods which are running in under the default namespaces. Okay, so as I said, we have a cluster. So inside the cluster we have something called as namespaces, which is a logical grouping. So we can type namespaces or simply namespace. So namespace is irrespective of is a resource which is at the cluster level. So you can see default, queued node lease, queue public, everything. And if I want to create so these are the default namespaces which would be get created. But yes, so these will also have something called as the pods. So let's call the pods with kubectl get pods. So this, if you do not pass parameter namespace, then it would get from the default. Okay, and if I go and I type something called as -n, and then, or what I can say is I'll just say, so remember, so when you use /, so it's just a single word you're gonna use, a single letter you're gonna use in kubectl, but when you give it with double dash, you have, it would be it's a big string or more than one letter. So you can see, so these many pods are running. So you can see all of these pods are running in the kube system itself. Okay, and so nothing in the default. Okay, so default is left, and this is all required to make your nodes and pods available. So these are the systems which help you in running your particular applications or your pods on AKS cluster. So we'll go ahead and let's create a namespace. Okay, for creating a namespace, so which is a logical grouping, you just mentioned I create an S and then namespace 1, which we created from the UI, but it didn't because it was not with the admin privilege. So I created my namespace, so I'll go get ns again, so I can see all of the namespaces and the new namespaces which got created. So okay, so we can also search something called as roles. Okay, let's see if any roles are there. Again, nothing in default, so I'll go with all namespaces. Okay, so no roles have been defined. Okay, so let's go and see whether any cluster roles are there. It should be there because we have OMS agent reader, everything. So the one which we were seeing in the dashboard in the previous video, which can see in here as well. Okay, so each role, cluster roles would require, because the agent is running, right? So they will have some roles to define, and there's something called as cluster role bindings. You will know more about them and further, but yes, let's go and check cluster role bindings. Yes, we have the cluster role bindings. So role bindings, cluster role bindings, cluster roles, roles are very specific. If you define cluster roles, it's specific to cluster. It's at cluster level. It would be designated cluster level. If you define roles, roles can be defined at namespace level as well. Similar thing goes with the role bindings as well. So role bindings you can mention with the name at namespace level, but cluster role bindings you would be mentioning at the cluster level. If you want to go and take a look into my GitHub repository, so this is a channel where I'll be posting these all videos which have a decent descriptions of what are the things which are going to come. So this is my channel. Thanks for the subscriber count. But like soon, probably with this AKS videos, I can achieve 600 or 1000K, and views are nice. Yes, if you have any issues with building up the image, you can always go with my Docker tutorial, which has complete installation for introduction and preparing an image out of it, running an image, everything. Yes, so we were talking about role binding, the cluster role binding, everything. Okay, so you can see here I have some file called as the role binding. So role binding, as I said, you can assign role bindings. Okay, or you can create a cluster role binding. So how exactly a role binding would look? So role binding, so these are all everything talks in are created in YAML. So you interact with cluster in YAML, and you have something called as API version. So it says RBAC.authorization. Okay, so this is there when you are using your RBAC cluster. So in that case it would be required, but not in our case. But in our case we can just go with the API version, which would be a little different from this. And you would use a kind it's a role binding or cluster role binding. It's a role, it's a service, or it's basically shows up the category. And you have the metadata or information, what exactly it does. It reads secrets, means the role binding name is given at the name. Okay, so read secrets is a role binding name, and the namespace is a development. Okay, and we have subjects, which is called as who is the subject, who can use, who cannot use. So something like you can give users, in case of RBAC you can give it the user, you can give it the AD group level, you can. So when you say it user, you either give a GUID or an email ID. Okay, and then this is a cluster role, which so this role binding is been applied at the cluster role level. Okay, so which is going to be like at namespace level, but it has a cluster context. So you have with something called a secret reader, and then we have something like this. So if you go back, and you always you can fork my code at the Sugar 007, and so let's go and look into cluster role. So cluster roles are this, and it's very simple. It will have an API group, which so always the roles are the things which will have actual permissions, what he can do, what he cannot do with a role. Okay, so if I'm a user in this particular, so this is my email ID, and I'm a user, I'm a tenant admin for this particular subscription. So what I can do, I cannot do, can be described by the tenant admin role. Okay, similarly, so there's something called cluster roles. So you can define cluster role, and what he can do and cannot do is defined in API groups in the rules on the verbs. Okay, what he can do, and he can fetch, he can watch, he can list, and he can take secrets only with this particular role. So you'll get more clarity once we jump onto each and everything. And just these are type of cluster roles which I have defined. And yes, if the more files if you go through, you will get an understanding. And one good part of AKS and like dealing with the YAML is you can define all the rows, everything in a single file, and then just trigger a single call. That's it, and it would be done. Okay, and this is how though I was talking about the cluster roles. We have something called as okay, so we said about the pods, right? Okay, and the pods we can get from the all namespaces. Okay, so these are the pods. So pods, as I said, we have cluster, we have nodes. Okay, let's go and get the nodes first. Okay, so nodes are at like cluster level, so you do not need to mention all namespaces. So this is the node. Okay, if you want to know, so this is the same node which you were seeing in the portal. Okay, so you were seeing in this particular portal, right? So you can see here MC underscore resource group. If you go, you were seeing the nodes in our particular VMSS. If you go to VSS instances, and then you can see, so these are the same, but the bit difference is the name. Naming convention is a bit different than this. So go back here, and what I can do is the beauty of kubectl commands is you can actually describe it. Okay, if you want to know more about the information about the nodes, you can describe, and anyway it's the node, so you do not need to mention which particular namespace, but yes, for the other resources you need to mention the namespace. So I'll go ahead and describe the nodes, and you can see this particular, it would show what particular image it is running, the kernel version, everything would be tagged, the CPU, memory, everything, A to Z information, disks which are attached is 4, as we've known with that while provisioning. And you can see if some disk errors or something is there, you can actually find in here. So network pressure, network unavailable, memory pressure, everything has been, if it is there, they would be true with the bool values. And these are the thing, this particular nodes, it says which particular agent pool it is running, and what is a cluster, the cluster bit, which particular resource group it is running. It mentions everything, and it shows also the internal IP, which is interesting. And then if you go scroll down, it gives a lot of information, and also each of the pods which are running on this particular nodes are how much capacity they are running on it. Okay, and these are the things which you can get from just from the nodes. Okay, and similarly you can actually if you go and get pods, if you can do the same thing for the pod. You can describe the pod and what where the applications are running. So as I said, so now it's time to deploy application, but I will take into consideration in the next video. But how we gonna deploy our application into it is like by using Helm charts. So Helm charts are like so what we do in the traditional way, we have binaries, we deploy the binaries in IIS and we run it, and the application is available, right? Similarly, these charts are like sort of binaries, okay, but they are more in the form of YAML standards. Okay, so we gonna use lot times Helm charts to deploy our services. So here it says Nginx Ingress. Okay, so we can deploy our Nginx Ingress with this. So it's very easy, it's just you go and Helm install stable Ingress, and then it says, but for that you need to have stable in your repository. So this is one way where you can get binaries and install your services on the cluster, or you can build an image, put on Docker Hub or onto the Azure Container Registry, and get this image pulled inside the cluster and make your service available. Okay, so these are the two ways where how you can do that. And in order to, okay, let's go and check what particular Helm version we are running. Okay, so it says we can, I think if I'm correct, it's Helm version v okay, yes, this is the Helm version we are running, so it's 3.111, and so since it's Cloudshell, it keeps it updated. But yes, let's go at the we need to add the stable. Let's try to get, okay, so you can see, you can Helm install, you should give the name of Nginx Nginx, but failed to download. It says let's run Helm repo update. Okay, so let's go and run Helm repo update, and even there is no repositories found, so we need to go ahead and add repo stable. So it will give some sort of space to repo to pull those binaries which we were okay, and repo name and flags. Okay, so I can go, I have the sources, I have my commands placed in Helm repo I can add this table. So I go ahead and then I add my repo, and then I just do Helm repo update. Now it would go and get the files which are there as part of this particular Helm. Okay, in this table, whatever binaries are there, it would pull all those binaries. Okay, so if you want to see the binaries version, it's pretty easy. So you just go and run one particular command and search repo. So you will see all those binaries which you were seeing there on the GitHub in here. So you can find Nginx as well, Nginx Ingress. So these are sort of services which are binaries which are available, and you can just take use of them. Okay, I go ahead and I would install, and probably I can install in my namespace 1. Let's see. I go ahead and I just get the binaries, and it would spin up my service. It says like the Nginx controller has been installed. Okay, so basically when we run something on AKS cluster, right, so it would create pod in most of the cases. So let's get pods namespaces, all namespaces. Okay, so you can see we have the pod, the container is getting created, which says Ingress controller, which is sort of service, because the Ingress controller will sit on top of our cluster in one particular specific node. Like in here, it would sit and it would keep tracking of all the traffic which is coming from outside world, and it would redirect the traffic accordingly. So if you're bored of running the command again and again to see the container created or not, you just add a postfix with watch, and then here you go. It would take care of of any state changes, since we see this particular container is already created. So you can just see the power of Kubernetes, how fast it is. Within seconds it has made your service up. Okay, yes, when I say service up, your pod is running, which means the container had created. Let's go and see our services. Okay, so we can get all our namespaces. You can see our service is running, the Nginx is running. So you can, it had tied up with the public IP because we allowed the public IP to be created. This says like your Nginx call, its Nginx is up and running. It just needs a default backend, which means that we have created a controller, which it's like traffic policeman who is standing, and he will see the traffic, and he will reroute where it need to go. But where it need to go, we didn't mention. So that we mentioned with the help of Ingress file. But yes, we will take that up in the next session. But yeah, so let's go. And so you can see there's a default backend which will be created, and the entries will be made by our Ingress files which we would create. And you can see it had hosted our application within no seconds and on this particular port. Okay, and since we have given the public IP, it always Nginx always gets tagged to a load balancer. And then even if you use UDR or something, and if you don't have public IP, it would try to create an internal load balancer and then tag the Ingress controller with the internal load balancer. Okay, since we have our the load, like external load balancer already, so it didn't create. But yes, let's refresh. So you can see there's another public IP which it creates when you create an Ingress controller with the help of Helm charts. So this is so you can distinguish between the defaultly created, because the name of the defaultly created would not be prefixed with Kubernetes dash, but the created one with Nginx will have the Kubernetes dash. So that's beauty of AKS, and we can go ahead and we can create Ingress within no time. But let me grab the file where we need to Ingress. So I'll show the Ingress, and this is the Ingress file. So you can see the Ingress file would look like this. So it would say the API version is blah blah blah, the kind is Ingress because I said it's an Ingress, and you can give the Ingress name and namespace you can target, and you can You can target like this is a Nginx class false, and as I said, like how much data you can actually allow the buffer, how much you can give is 64K. And here grafana.unipapps.com, this is one particular example where I've tied up with my particular domain service, because I've exposed I created an SSL certificate somewhere from and on this particular domain, and then I've tagged my service so that my service is all available outside the world. So in order to do or make your service available out of this and tag SSL certificate, you will create an entry of secrets in AKS. So that we will know in our next sessions. So basically we create with a TLS key. So TLS key will create a secret and we'll mention TLS, so it would route your traffic to HTTPS. Okay, so even you mention HTTP and the port, because the SSL termination will happen and it would pick up the certificate from the widget secret. So the secrets are, you know, so we have concept of secrets in here as well. So I'll say, like, you know, so these are the default secrets which would have been created by Nginx and other stuff, but you can create your own secret. Like you can keep your certificates as in the form of secrets, and your whenever SSL connection sets up, it can use that particular certificate to authenticate and set up that particular session. Okay, so with this I'll go ahead and I'll deprovision this particular pods. So how do you deprovision? So it's easy. So deprovisioning is like, since the best is, you know, how do you tackle resources in Azure? If you want to delete resources in Azure, you just go delete and resource group. Like here, if I want to delete everything, I can just go to resource group and delete resource group. Similarly, in here as well, in AKS also, you can delete the resources just by deleting the namespace. So I have the namespace 1. So it will go ahead and delete the resource. It will take little time because it would be deleting your deployments. I didn't show you deployments. So deployment is a first parameter which triggers your service. Okay, so deployments are also categorized, so I can show deployments in the next session. And we have so it will delete your deployments and services, pods, containers, everything from that particular which have been, you know, provisioned in this particular namespace context. Okay, and that's one. And once the deletion completes, I'll show you. Yep, the deletion completed. So you can go see get secrets. You won't see the namespace. You cannot see the namespace 1 because it's deleted. You cannot see the service because it's deleted. You cannot see the pods because that's also deleted. So that's a beauty. So I was saying about the deployments, right? So if you can go and type deployments, so you can see the deployments. So before creating service, it would create deployments. So the replica sets will, you know, it will also say how many replicas or, you know, the deployments will happen. Okay, and yes, with this, and like I'll also show how to delete your cluster. So the cluster deletion is easy. So you just go delete your cluster here, and it would take care of deleting all your secondary resource groups which you have created. But there is a clause, like, you know, the log analytics workspace will not be deleted. The resource group will be there, but it would empty. But the MC_resource group would be deleted with this particular deletion process. Okay, let's go and